So in this example, we're going to consider not just a single force, but more than one force. So we have to remember that when we deal with Newton's second law, it's the sum of the forces that is equal to the mass times the acceleration. And when we sum forces, we have to add them like vectors. So in a game of tug of war, you have two teams that are pulling in opposite directions on a rope that has a 15 kilogram mass tied to the center. We know that one team pulls to the right with a force of 18 newtons, the other to the left with a force of 12 newtons. And we want to know what's the acceleration of that mass at the center of the rope. And then if the mass has to travel 0.5 meters before a winner is declared, how long does that take? So we can sketch a picture for this. Here we have the 15 kilogram mass in the center, and then the forces on either side, the 18 newton force pulling to the right, and the 12 newton force pulling to the left. Now, because these are in opposite directions, the sum of these forces is really going to be the difference. 18 newtons to the right, 12 newtons to the left. That means that the net force, the sum of the forces on this object, is 6 newtons to the right. 18 minus 12. So if we take the sum of the forces, set it equal to the mass times the acceleration. By the way, we have 18 newtons minus 12 newtons. We can set that equal to the mass times the acceleration. To determine A, we just solve. We find the acceleration is equal to 0.4 meters per second squared. And since we know the acceleration, we can use the acceleration and the fact that we know the displacement it has to travel to determine the time that it takes for someone to win the tug of war. So once again, the acceleration is 0.4 meters per second squared. The distance that the mass has to travel is 0.5 meters. When they first start the tug of war, the initial velocity is 0. The mass is not moving. And so we can determine the time that it takes for the mass to travel that distance using the second kinematic equation. Again, the initial velocity is 0, so we can just leave that part out. And we know the displacement is equal to 1/2 a times t squared. If we then plug in the values that we know and solve for t, we can find the time that it takes for one of the groups to win the tug of war. So we find that the time squared is equal to 2.5 seconds squared. When we take the square root, we find that the time it takes for one of the teams to win the tug of war is 1.58 seconds.